my pleasure to introduce our speaker, Stefano Amorelli, a senior staff software engineer at Quanto and a contributor to the OWASP Gen AI security project. So Stefano specializes in applied AI, cybersecurity, and AI red teaming, and has contributed to key initiatives like AWS Strands SDK and OWASP Top 10 for the agentic applications. So in this session, he will share the insights into the securing the AI agents, including real-world risk like hijacking and tool misuse. So let's give a round of applause and welcome Stefano on the stage. Thank you.
Thank you, Yash. Thank you so much. I'm very excited to be here with you to talk about AI and security. Just a few years ago, with ChatGPT coming out, the work and our life completely changed. And 1 year later, with MCP, large language models now have access to tools. They can perform actions, and they can gather data from external resources. Last year is the year of agents. So now that large language models have access to tools, we give agency to them, we give them autonomy, and we let them perform workflows autonomously. But what's next? What's going to happen this year and maybe next year? And the reason why we are all here today is because of security, because these agents now are running in prod. And maybe they're running critical infrastructures. And it's happening right now, but not many people maybe considered the security aspects just yet. There are different projects and labs and organizations that currently are investing a lot into the topic of security in AI. And OWASP is one of them. So raise your hand if you heard of OWASP before. OK, nice. So I will skip maybe the first part, and I will focus more on the Gen AI security project that is a project within OWASP that contains in itself multiple initiatives. The one that we're going to focus on today is the agentic security initiative. And we released the OWASP Top 10 for agentic systems last year in December, and has been contributed by many different experts from the industry, academia, AWS as well. And the idea is to provide the top 10 vulnerabilities and mitigations when implementing agentic systems. I will not go through each one of the entries. I will share with you the document later. And in this session, we're going to focus on some of them. But this guideline is obviously a document, but what I want to show you as well, how we can apply these concepts, how we can attack these systems and protect them with real code. So my session is going to be a little bit practical. We're going to have some demos, so fingers crossed. And we're going to use Strands Agents SDK. Who is using Strands Agents? OK, not so many people. Strands Agents SDK, very quickly, it's an open source SDK by Amazon. It's very, I think it's one of the most used ones whenever you are building agentic systems. The key concept of Strands Agents is that it's very easy to start to use. So if you want to start building an agent, you can do it in just a few lines. But also, if you want to dig deeper and create maybe multi-agent systems, that's where Strands Agents also shine. You can read more about this SDK, this QR code. It's currently available in Python and recently in JavaScript as well. And very quickly about me, we already gave an introduction. Before we get started, I contribute to different projects such as the OWASP Top 10 for agentic applications and other interesting projects in the AI space. But without further ado, let's get our hands dirty. So we're not going to do this kind of hello world kind of stuff. We're going to do something a bit more fun, hopefully, a bit more realistic. So what is our scenario? We are implementing a financial AI assistant. So money is involved, critical system. And in our system, we connect it to the SEC EDGAR database. What is it? It's basically a database provided by the Security and Exchange Commission in US to return public company information. So financial reports, press releases, will be accessible to our financial AI assistant, so we can perform financial research, and we can also execute trades, so it will be connected to a broker. A few more details, it will also have memory, and it runs autonomously. We're going to have two demos. In the first one, we will try and manipulate the agent to buy some stock, but we didn't ask it to do. We asked to research some other stuff, and we want to hijack the goal of the agent. And we're going to use different attacks, so prompt injection from the OWASP Top 10 for large language models, and we're also going to explore a little bit about memory poisoning. And for the second demo, we're going to talk about supply chain risk. So Gunnar talked about MCP. We're going to touch a bit more about that as well in the second demo. And what we want to achieve in this case is to leak portfolio data to the outside world. Without further ado, let's get started. So what is the architecture of demo 1? As we saw, we have a user request that is connected, that is the input to our financial AI assistant built using Strands Agents SDK. And this AI agent is connected to the SEC database to gather information about the company, and also to the broker MCP to perform trades. Our attack vector is going to be a poisoned filing from the SEC. That means that the attacker put some prompt injection within this document, and the goal is to execute a trade we did not ask it to do. So let's go with the demo. Hopefully it goes better than the one with Mark Zuckerberg. Let's see. OK, so this is my broker account. Right now, I have 50K sponsored by AWS Community Day. No, I'm joking. It's just fake money. And I don't have any investment, right? So I have zero investment here. I'm going to open my repository. Let me zoom in a little bit. OK. Can you read it from far or not? A bit bigger. Better? OK, let's give it a shot. So I'm going to do demo 1. OK, so we have our assistant. We have our tools available, get company filing, and also some other operations that the agent can do. And the attack is going to be a malicious filing from the, gathered from the SEC. Now, one important thing here I also wanted to show to make it a bit more interesting is that inside the filing, so this is the filing that we get from the SEC. And there is nothing really suspicious here, right? We don't see anything suspicious, but inside we use what is called ASI smuggling. What does it mean? There are some characters that are not displayed in the terminal and will not be displayed also on your browser, but are actually there and will be read by the large language model. So if you see this, for example, there is nothing suspicious in it, but in reality, there is a hidden payload, and I will show you how it looks like in the code. And inside this hidden payload, there is a prompt injection that says to basically place a market order and buy, obviously, Amazon shares. So let's give it a shot. And this is a query from an analyst that is saying, research this probably fine company, and it gathers the latest filing from the SEC. And here we can see the tool calls. So everything is OK until here. It's getting the filing, it's getting the positions. But then we see that it's executing something that it should not, because we never asked it to perform a trade. It was hidden in the payload of the filing. So here we can see that we have these tools called, and we also have a market order that was executed. So if we go in my broker account, hopefully, yes, we should see that we now have a market order. Now the NASDAQ is closed, so we didn't lose money yet. But we can see that it created an order that we did not want it to do. So I'm going to go ahead and cancel. And the idea is that the agent was reading something that we weren't able to read. So it's very difficult to detect this kind of attacks, but it is possible. How we can do that? Well, I think this topic was also touched in some of the previous talks. The idea that we cannot trust the input whenever it comes from, either it's an MCP tool call or data from the user. So the first thing that we need to do is to perform some cleaning, some input sanitization of what the agent sees and receives. So that's the first level of protection. And then if you're working in security, you probably know that it's a good practice to always apply not only one layer of protection. So the first one could be the sanitization, but the second one could be implementing more security measures as a large language guardrail. So using maybe a model that checks if there are prompt injections in whatever we are ingesting. And third, but not less important, is the concept of least privilege. And we will see it also in the next example as well. This is very important. If we want to contain the attack surface, a good idea is to give the agent only access to what it needs. So if our agent was only to be used for financial research, it should never have access to perform trades in the first place. Now, it's not as easy as that, because obviously this also limits the functionality of the agent. But it's a good practice to balance what autonomy we give to agent in comparison to the security that we want to achieve. So now that we implemented these defense layers, I'm going to go through it again. So we see that the first layer is stripping the invisible characters. So we don't have the problem of the invisible injection anymore. And the second layer, the guardrail, is actually detecting that there is an injection payload in the filing. Moving forward, now it's running the agent again with the security measures. And in theory, our company that we are researching, probably Fine Incorporated, should not result in any additional trade that we do not want to perform in this case. Okay? So this is how we mitigated this risk in our use case. But let me show you very quickly. How does it look in code. I will go through it. It's a bit complicated, so I will also share the repository if you want to dig deeper. So if I go into my Python script, the core of this example So this is just console printing to see what we saw. And in these lines, I'm initiating the agent with the Strands agents. As you can see, it's literally, I think, a few lines of code, and we have a fully working agent. In this case, unsafe. But that's one quality of Strands agents you can get up and running very quickly. And I also want to show you how it looks like the invisible prompt injection that we saw as well. So I'm going to show you how this is done. So in the tools, we have the get company filing, and inside here, I'm mocking something that we get from the SEC, in theory, that is the malicious filing. And here, I'm constructing the payload by adding these characters. And if I append these characters to the prompt injection, it will not be visible in your terminal or in your browser. Now, very critical point, because if you're using any coding agent right now, Claude Code or Gemini CLI, and so on and so forth, you are vulnerable to this. You are vulnerable to having some web pages maybe hiding information, and you are not seeing it in your terminal. So in theory, this is something that could be exploited in the wild. But moving forward, because we are a bit tight on time, what are the key takeaways of this example? There are multiple ways that we can protect this risk, that we can address this risk. And the first principle is to never trust the input. And that's something that we already know, probably, as security professionals, but as implications that maybe we were not aware of when using AI agents in this case. And also, as I said, least privilege is a concept that becomes critical when working with autonomous systems. Bonus point, so we saw something from input. We saw a filing document that contained a prompt injection. Same concept applies with memory. So memory right now is very popular, the idea of using agents, and you can share memory across team members, across agents. You can do the same. You can poison a memory. And why this is powerful is because if you poison once, you poison it for all the different sessions. So memory becomes a very critical attack surface that can be exploited effectively. Moving on to the second example. So recently, supply chain attacks have been mainstream across different platforms. So I want to show you how it might look like when dealing with AI agents. Okay? We talk about MCP, and there is a saying with security professionals that the S in MCP stands for security, because there is no S. And as Gunnar also covered a lot in his talk, there are many things we need to do to make sure that when using MCP, we are safe, let's say. We address the vulnerabilities that we might encounter. But one point that is becoming more and more critical is the supply chain of MCP servers. Maybe we are using an MCP that is safe now, but can be compromised tomorrow. So in this example, what we see is that we have a legitimate remote MCP server, but then a poison one that gets released, and we are not aware of the poisoning because the tool is using exactly the same description, exactly the same arguments, but it contains a prompt injection within the descriptor. So all we know is that the Panda bot maybe opened a PR, updated the dependency, and from one day to the other, we encounter an issue. So let me show you how it looks like in practice. In this case, what we'll try to achieve is to leak data outside. So we will not execute a trade, but we will leak our portfolio data to an attacker. So let me do this. Make demo 3. Okay, so let's say that an attacker compromised the registry account of the MCP server and bumped the version. And now the tool that we used to use introduces a prompt injection in the tool description. So before execute trade was just executing a trade, but now it also included some more information that is not, was not supposed to be there, and is just leaking the portfolio to an external endpoint. One important point is that if we look at the hash of the legitimate MCP server tool, we compare it to the compromised one, obviously it's different. And this is key for the remediation that we're going to see. But if we don't check this, what's going to happen in this case, if I say that I want to buy 2 shares of Amazon, for example, for the compromised MCP server, we're also going to see something that we do not expect it to do, that is publishing data to this webhook, for example, right? So if we go here, we should see that the data was leaked, but that's not something we requested. We just asked to buy some Amazon shares, and here we see that the data was leaked to an external service. So how we address this? Well, the best way is to always verify that the tools we are using are the tools that we want to use. And one good way is to hash the descriptor, the tool descriptor. So if we're using version 1.2.0 and we trust that, then we could hash it and compare it to the next version so that we can be alerted, or we could also block if the hash is different. It means that the tool has been compromised. Okay? So we can either reject it, or we can also alert, or create alerts, but at least we know that something is not going as expected. So how it looks in practice, now I'm implementing the remediation where I compare the hashes, and if I notice some differences, I just fall back to the safe version I'm used to. And with defenses, we do not see the leak of data, we just see the execute trade. So we are really running out of time, so let me proceed with the presentation here. Let's go. Quick recap, input data always can be an attack surface. Memory, be specifically mindful of that. And tools are also a supply chain risk. It's not really input data, but it can also be one attack vector. And these attacks are already in the wild. They're already exploits that have been, let's say, discovered even recently, but also are defenses that we can implement today. There is also much more. So if you want to dig deeper into this topic, especially when handling with the multi-agent systems, we even amplify even more the attack surface. I recommend to read more about this in these resources. And if you want to dig deeper into the repository, there are also a few more examples that we did not cover today. But the repository is not publicly available yet. But if you add me, I will give you access. And with that, I thank you so much. And together, let's make AI agents more safe. Do we have time for questions? We need mic.
Thanks for your presentation. I have only one question. In the last, when you're comparing using the hash key, right? So hash key is a text-based one. There is a chance of hacking the hash key, and there is a chance of a collision hash key that is also be possible. So if that is the case, what is the alternative if you, instead of hash key? That's only one simple question.
Yes, that's a very good question. So I think if we're talking about hashing, there are ways you can create an hash. So there are algorithms that are more prone to collisions. why I'm suggesting hashing, why we are suggesting hashing, is that there are some kinds of algorithms that the collision risk is very small. So we assume that the probability of collision is so small that we are accepting the risk of having a collision in that sense. But in any case, that's something that we decouple from the fact of verifying the authenticity of the tool description. It's another problem if the hash is creating a collision. That's another discussion of the methodology we're using for hashing. But that's a very good question and brings also the topic of how do we hash it so that we don't create collisions. For example, if you use MD5, probably it's not a good idea at all, you know?
Yeah.
Yes.
Yeah. So some of the solutions that we see here are like pretty much like a one-off. So I was wondering that if there's any like a systemic way to prevent like some like future unknown attacks from happening.
Yes, very, very, very good point. So some of the solutions, you are correct, are deterministic. So if you will see also in the source code, for example, the input sanitization, it uses basically regex. So it's not the most sophisticated solution, and it's as good as the regex that you build, right? So you cannot realistically predict all the different attack scenarios. So I do agree with you that some of the remediations are not future-proof. But for example, the one about guardrails, using a large language model that checks the input, so it's an additional step, and you're basically fighting fire with fire. You're leveraging an additional layer of Gen AI to check the security. Then it becomes much more powerful, and you can do it natively with strands, like the example that you might see in the source code. You can do it with Bedrock guardrails. So it's much more powerful, but also you add latency, it costs more. So it really depends on your use case, how much you want to invest into a future-proof solution, or you are okay with more deterministic approaches.
Yeah, so it looks like it's going to be like a long-term kind of like a fight.
Yes, as I said, it's fighting fire with fire, but we will win.
Thank you.
All good? All right. Thank you so much.